Only 10% of Alberta's oil sands deposits are close enough to the surface to be mined. The vast majority of recoverable reserves, over 140 billion barrels of bitumen, can only be recovered in situ or in place, very much like conventional oil with minimal land disturbance. All thermal in-situ recovery works on the same basic principles. Steam is used to heat the bitumen or heavy oil, which reduces its viscosity and allows it to flow towards a collection well, either by gravity or induced pressure. There are three methods of thermal recovery used in the oil sands: steam flooding, cyclic steam stimulation, and steam-assisted gravity drainage. Steam flooding was first developed for heavy oil reservoirs in California and Venezuela as far back as the 1950s. Steam is injected into the ground, heating the heavy oil and pushing it towards a production well. When tested in the oil sands, it used too much steam and wasn't found to be very efficient. Imperial Oil began testing cyclic steam stimulation in the 1960s. Instead of continuously injecting steam, CSS involves cycling through steaming, soaking, and production cycles, making it a lot more efficient than traditional steam flooding. Cyclic steam stimulation technology was commercialized in the Cold Lake and Peace River areas in the mid-1980s. However, when tested in the much larger Athabasca region, it didn't work so well. Directional drilling technology came along in the 1990s, enabling for more accurate well placement. A production well was drilled into the bottom of the reservoir, and steam was injected into a top well, perfectly stacked a few meters above it. The condensed steam rises up through the reservoir, heating the bitumen, which then gravity flows to the lower production well. Steam-assisted gravity drainage was commercialized in 2001 and works exceptionally well in the Athabasca area, which now accounts for well over 1 million barrels per day of in-situ production. So the big question is, why did it take so long? Why does steam flooding work well for heavy oil, but not so great in the oil sands? And why does CSS work well in the Cold Lake and Peace River areas, but not so well in the Athabasca area? And why did it take the industry over 5 decades to finally unlock this massive resource? The short answer is reservoir geology, which is very different in the oil sands versus other heavy oil deposits, and even varies across the 3 different basins. Hi, my name is Anna, and I'm the editor of Oil Sands Magazine. If you're interested in learning more about oil sands geology, I would invite you to check out our latest course. We'll take a look at the different geological formations found in the oil sands, what makes them so challenging, and the various thermal extraction techniques used among in-situ operators. We'll cover the 3 most common oil-bearing formations in the oil sands, zeroing in on the Clearwater Formation in Cold Lake, which uses mostly cyclic steam stimulation, and the McMurray Formation in the Athabasca region, which is developed using steam-assisted gravity drainage. We'll look at the geological differences between these areas, including deposit depth, pay thickness, cap rock integrity, porosity and permeability of the pay zone, bitumen saturation rates, and oil quality for each area, and finally the presence of thief zones, which all have a profound effect on reservoir performance and steam-to-oil ratios. And finally, we'll end with a quick overview of all the operating thermal in-situ facilities in the oil sands and the production methods used to extract bitumen. This course is split into 6 chapters and includes a PDF slide deck, video transcript, and full list of references. For more information, check out the links below. Thanks for watching and hope to see you next time. Bye for now.